All right, 6.6 is inequality in two triangles. The essential question says that if two sides of one triangle are congruent to two sides of another triangle, what can you say about the third sides of the triangle? All right, so we'll look at answering this question. What you are expected to learn at the end of this is you'll be able to compare measures in triangles. You'll be able to solve some real-life problems using something called the Hinge Theorem. Alright, so here is the Hinge Theorem, and it says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, that means that the third side of the first triangle is longer than the third side of the second triangle. And basically, let's draw this out so that you can see what I'm talking about. And it should be kind of common sense, I think. I hope. So let's say I have this triangle here, and we'll call this first triangle VXW. And then we have another triangle, looks something maybe like this, where I have RST here. And let's say that I know that VX is congruent to RT and VW is congruent to RS. Okay. The angles here, angle V and angle R, that's going to determine which of these third sides is longer. So if I know that this one happens to be 88 degrees and this one happens to be, I don't know, say 35 degrees, okay, since this angle here is larger, that means this side right here, this segment XW, is going to be longer than this segment TS. Alright, so let's just kind of say that the distance from WX, that length, is greater than the length of ST. Okay. That would be the conclusion based on the Hinge Theorem. Alright, so let's look at another example here of how to use the Hinge Theorem. We're told that the segment JK is congruent to segment LK. And we want to compare the length of JM to the length of LM. Okay. Well, I do have two pairs of corresponding sides because I know JK and LK are congruent. Then we have this segment here in the middle, this KM. Okay. This segment is part of both triangles, so according to the reflexive property, it's congruent to itself. And so we could make a decision on JM and LM using that, because this angle 64 is greater than this angle measure 61. That means JM has to be greater than the length of LM. Okay, so now let's look at the converse of the Hinge Theorem. And that just reads that if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle has to be bigger than the included angle of the second triangle. So kind of the same idea. I do have two triangles here. Call this one, I don't know, ABC. And we have another triangle here. We'll call it DEF. Okay, and the same kind of hypothesis. I know I have two pairs of corresponding sides that are congruent. So let's say BC is congruent to EF, and I know AC is congruent to DF. Okay. This time, instead of giving you the angle measures, we're going to go backwards and say, okay, I know the length of AB is 12, and the length of DE is 9. Okay. Because this side here is longer than this side over here, that tells me that angle C, or the measure of angle C, has to be greater than the measure of angle F. Okay, so this would be the converse of the Hinge Theorem. Alright, so let's look at an example here using the converse of the Hinge Theorem. We're told that, or we're given that segment ST is congruent to segment PR. That's what the tick marks are for. Alright, and we want to look at the angles PST, which is this angle right here. How does that compare to the angle SPR, which is up here? Okay. So, again, I have to have two sets of corresponding congruent sides. So I know this one, ST, is congruent to PR. Okay. And then again, since the two triangles are back to back or next to each other, they're connected, I know PS is congruent to PS by the reflexive property. So I have my two pairs of sides that are congruent. Now I'm looking at this angle here, so I'm going to go backwards across this way. I have an angle or a length of 24, excuse me, and a length of 23. Since this side here, PT, is greater than this side over here of RS, the segment, that tells me that the measure of angle PST, that has to be greater than the measure of angle SPR. I don't know the actual measurements, but I know that this angle has to be bigger than this angle up here. Alright, example 3, here's a real life problem. Two groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles, then changes directions and travels 1.2 miles. So group A starts by going due east and then turns 45 degrees north. Group B starts west and turns 30 degrees south. Okay, which group is farther from the camp? All right, so I went ahead and have the picture here drawn. So the camp is right here. Okay, they're both going 2 miles in opposite directions. So group B is going 2 miles west, group A is going 2 miles east. Okay, the difference or what happens here is when they turn to go in different directions. So if I'm going here, the way this is done, I'm going east, and then I go 45 degrees north. Okay, so that's this curvature, that's where this angle turns. Okay, same thing with the group B. I'm going west, then I turn from this horizontal line, I go 30 degrees south. Okay, notice that the 30 and the 45, that's outside the triangle. So in order to do this, we have to look inside the triangle. So what's going to come out is, notice I have this straight line, so I have to do 180 minus 45. Okay, that gives me an angle measure here of 135 degrees. Okay, because the Hinge theorem, I had to look at two triangles. Okay, and I had to match the corresponding sides. So I have the 2 miles and 2 miles, and I have the 1.2 and the 1.2. So I need this angle here to decide if this distance is greater or less than this distance here. Okay, so on the other side, we're going to do the same thing. I got to do 180 minus 30. That gives me 150. Okay, so this angle in here, inside the triangle, is 150 degrees. Okay, and since this angle measure here is greater than this measure here, that tells me that group B is furthest from the camp. Okay, so group B is further away than group A because of the Hinge theorem.